Good morning to our friends in Western Canada, and good afternoon to our friends in Eastern Canada. Welcome to our webinar, Role of Canada's Forest Sector for Economic Growth and Climate Change Mitigation. This webinar has been organized jointly by the Canadian Academy of Engineering and the Canadian Forest Service of Canada's Department of Natural Resources, and with the full support from FPInnovations. This webinar is one in a series of net zero webinars being organized by the Academy of Engineering. My name is Oscar Sigvaldason. I have the very distinct pleasure of serving as your moderator for this very important and timely webinar. I'm honored to have been selected by the three supporting organizations for this role. This has arisen from having worked jointly with the Canadian Forest Service and FPInnovations, along with other Canadian specialists on improving understanding of climate change mitigation possibilities for the forest sector. More specifically, this has included application of best in global practice systems methodology for deriving optimal solutions as decision aids for defining forest sector strategies that contribute to Canada's economy and climate change mitigation. Canada's forest sector is a very important sector for Canada. 9% of the world's forests are in Canada. Canada has one of the largest forest carbon reserves in the world, and Canada is the largest global exporter of building lumber. With our nation's challenge for meeting very ambitious GHG emissions reductions of 40 to 45% below 2005 level by 2030 and net zero by 2050, there is a need and potential for Canada's forest sector to increase its role. This includes strategies for greater sequestration of carbon that at the same time contribute to economic growth, to serve an expanding domestic market, and for increased export. To meet these challenges, many significant transformations will need to happen between now and 2050. In my brief introductory comments, I will highlight three of the most important transformational themes for Canada's forest sector. The presenters will expand on these transformational themes. The first major transformational theme is the potential for increased production, use, and export of long-lived harvested wood products. This includes especially production of lumber, cross-laminated timber, and strand board for building construction. The benefits include long-lived carbon retention or storage for building materials, while correspondingly reducing the use of concrete and steel, both of which are very carbon-intensive building materials. This first theme also includes production of other new and emerging higher-value bioproducts, such as biochemicals, bioplastics, and biopolymers. These are intended to replace production from GHG-emitting hydrocarbon sources. The second major transformational theme is related to optimal use of biomass or forest-based biofuels for energy production. One key point here is the need for realism about the availability of biomass for energy. It is limited, and anyone interested in biomass for this purpose needs to pay close attention to whether there's actually adequate supply for this purpose. The concept of burning biomass or forest-based biofuels attracts a lot of attention and often controversy. Burning biomass and energy results in emissions, but depending on a lot of factors, including the time period of interest, there may or may not be a net mitigation benefit. Such factors include, for example, which feedstock is used, timber, wood fiber, mill residues, or wood waste. This places special emphasis on rigorous carbon accounting to ensure that all relevant factors are reflected in the analyses for such applications. There are important strategic options with bioenergy, including use of carbon capture and storage when burning biomass or biofuels, including black liquor from pulp mills, or converting biomass to hydrogen. The third transformational theme is related to the forest management challenge, which is already very complex, and with the added challenge of transitioning to a very different future as a result of a changing climate. This includes all aspects of sustainable forest management, including harvesting processes, efficiency and conservation improvements, life cycle management, reducing damage from forest fires and insects, and managing activities over large geographic regions. The added management challenges, including increased afforestation and reforestation, increasing productivity for timber and wood fiber production, optimizing development and use of these products and associated forest residues, and managing forest products through their full life cycle, including various reuse options. Because of this overall complexity, it's essential that analysis, selection, and implementation of future strategies for optimal use of forest resources be based on comprehensive analyses for decision support that reflect interplays with other sectors of the Canadian economy, while maintaining overall benefits for Canada. It is important that the energy policy environment as related to the forest sector be visionary and adaptive, for ensuring that development and use of Canada's forest resources are consistent with maximizing both economic opportunities and carbon sequestration. We are very honored and pleased to have three very distinguished experts with us today. They will provide us with in-depth context on existing practices and progress in implementing transformative changes, in describing challenges ahead, and emphasizing the importance of comprehensive planning and a visionary policy framework. From this and with visionary leadership, it should be possible over the next 3 decades to work systematically towards ensuring that Canada's forest sector contributes to maximizing economic opportunities, for maximizing contributions to climate change mitigation, and for serving the many other environmental and societal benefits available from Canada's vast forest resources. I would now like to describe briefly the logistics for the 75-minute webinar. The 3 speakers will each give their presentation in turn. This will be followed by a question and answer period before brief concluding comments by each of the presenters. Attendees to this webinar are encouraged to ask questions through the Q&A tab on the website. Responses will be provided by the presenters during the Q&A period. We recognize that there's a possibility that not all queries will be addressed during the designated Q&A period. Accordingly, the presenters have graciously agreed to stay on for an extra 15 minutes to provide further responses to such additional queries. I now have the distinct pleasure in introducing the 3 presenters for this webinar. Diane Nicholls is Assistant Deputy Minister and Chief Forester for the Province of British Columbia. The title of her presentation is Transforming the Forest Sector, Climate Action and Economic Opportunities. Her presentation will be followed by Werner Kurz, who is a Senior Research Scientist at Canadian Forest Service of Natural Resources Canada. He leads development of Canada's national carbon monitoring, accounting and reporting system, as well as Wildfire and Carbon Project for the Pacific Institute for Climate Solutions, PICS. The title of his presentation is Forest Sector Contribution to Net Zero Pathways, Risks and Opportunities. Warren Mabey, our third speaker, is Associated Dean and Director of School of Public Policy at Queen's University. He's also Canada Research Chair in Renewable Energy Development and Implementation, with specialty in bioenergy technology and policy. The title of his presentation is Forest Products in a Net Zero Future, Barriers and Solutions. So that concludes my introductory comments, and it's over to you, Diane.
Thank you very much, Oscar. Just wait for my presentation to come up. But while that is coming up, I'd just like to thank the organizers of this webinar for inviting me to speak to you today. I understand there's quite an audience out there, so I'm not going to say good morning as it is in British Columbia, but rather a good day to everybody. So transforming the forest sector, climate action and economic opportunities. I'll be speaking to you today about the context of British Columbia and what our driving forces are and what our thinking is looking like for the future. As I was introduced, I'm Diane Nicholls. For those of you who don't know me, I'm a registered professional forester and chief forester for the province of British Columbia and an assistant deputy minister for the office of the chief forester. Next slide. So what I'll cover today is a bit of a takeaway message, a little bit of overview of the BC forest sector for those of you not familiar with it, some key drivers of change that we're seeing in British Columbia and elsewhere, BC's approach to transformation, and what comes next for British Columbia. Next slide. So a takeaway message. You may wonder, why am I putting this up at the beginning of the presentation rather than at the end? I think it's important to look at, what we have to be thinking about and going forward. And in transformation of the forest sector, I want to be sure to acknowledge that it provides opportunities to ensure future economic development, combat the impacts of climate change, and contribute to emissions reduction. We know our forests play a key role in all of this, whether it be setting aside old growth areas or whether it be intensive forest managements for thrifty, mature, fast-growing trees. There's always a role for forestry in our fight against climate change. And in British Columbia, forestry is a key driver of our economy. So it's important that we always be looking at the past, the present, and the future with regards to our economic generations and the ability of our forest sector to be strong and adaptable. A good example of this in British Columbia was we had some would say a climatic event in the sense of the mountain pine beetle with warming that has been occurring. And over the early 2000s, we had mountain pine beetle attack at the central part of British Columbia in a very large, impactful way. And a lot of our pine stems were killed by the mountain pine beetle. At the early stages of that epidemic, the forest sector was very worried about not being able to utilize the wood because it had a blue stain aspect to it, and they were concerned about the strength qualities of that wood for production of dimensional lumber. But through science and coordination of policies and actions in British Columbia, we were able to determine the strength qualities were still useful. And in fact, there was a blue stain lumber that became quite a design niche for a type of lumber to be used in certain aspects. Next slide. So what are the key drivers of change in British Columbia that we're seeing? We are undergoing a significant change in policy and direction with our government, but the key drivers of that change are four aspects that I'm showing here. One is climate change. We all know it. Wildfires. We had the heat dome this summer, drought from that, an increase in pests and disease that are having impacts on our forest health, and a change of types of precipitation. Very important, because what we're seeing is snow levels are decreasing, rain levels are increasing, storm events are increasing rather than continuous precipitation. So big dumps of snow and water rather than an ongoing onslaught. We're seeing these changes across British Columbia, and it is definitely affecting our forests. So we have to change the way we've been doing. We have to learn from our forest management, adapt to those practices so that it encompasses the learnings that we have of climate change so that our forests are healthy and resilient into the future. Another big driver of change in British Columbia, of course, and Canada as a whole, is reconciliation with Indigenous peoples. British Columbia has a Declaration on the Rights of Indigenous Peoples Act implementation, and we will require changes in policy and operation. We have a recent court case with the Blueberry First Nation decision, which is a treaty nation in British Columbia. We don't have many treaty nations in British Columbia, but the decision set out new responsibilities for government with regards to cumulative effects on traditional territories and the effects that that has on the natural environment that nations rely on. The third driver is due to elements of climate change in particular and new practices. because of that. And when I'm talking about climate change effects, I'm referring back to the mountain pine beetle. I'm referring back to the record events of allowable annual cuts having to be reactive to, such as the wildfires that we've had, which are over 2017 and 18, and just recently last year, and the rest of Canada also was hit hard with wildfires, and then the precipitous drought. We're looking at impacts of our growing stock in our forests, and that's leading to reduction in annual allowable cuts. And what that results in is in an interesting dynamic with regards to timber supply for dimensional lumber, and trying to make sure that every tree cut, the full tree is utilized. And a new way of looking at things that we used to call, coin a phrase in the industry of waste wood, is now opportunity wood. And then the fourth driver, of course, is old growth protection. Those of you who are watching politics in British Columbia, you'll know that we've had an old growth strategic review done, provided 14 recommendations for management of old growth forests. The first initiation of that old growth strategic review has been some deferred areas in British Columbia for rare, ancient, and large trees. And that is another component, because it will affect how we do forestry in British Columbia and where we do forestry in British Columbia, and is in unison with regards to reconciliation on how we want to manage old growth and ecosystems into the future. Next slide. So what is BC's approach to transformation given these drivers? The approach is captured in a number of different documents that are available, and it's really based on holistic principle and the sense of creating forest sector participation, enhanced stewardship and sustainability, very much strengthening the social contract, driving reconciliation with Indigenous nations, and focusing both on climate mitigation and climate adaptation. You'll see we've got the climate preparedness and adaptation strategy that's fairly new, Clean BC. The roadmap to 2050 has been is out there and has just been acknowledged in the global context of the Glasgow conference. And modernizing forest policy in British Columbia is an intentions paper of 20 intentions of change that the government of British Columbia is initiating. Next slide. So what all these changes drive us to is looking at, as I referred to earlier, about using the whole tree in British Columbia for every tree harvested, and pushing, which is the intention of the government of British Columbia currently, of pushing a value added rather than a volume focused competitive sector. We've done some analysis, and that's the graphic that we're showing there. And the suggestion of this graphic is not that you pick only one of these elements. It's really you pick all of the elements in this graphic, in the sense of the pyramid of value, I call it. Because you need foundational, in British Columbia at least, we need foundational wood products, dimensional wood products, building products. You know, we were built on the 2x4 saw log situation in British Columbia. And we also have pulp and pellets that rely on the residuals from that sawmilling enterprise. So we definitely need to keep that as our foundation in British Columbia, but you can create a more circular economy for the different fibers that are resulting from any kind of harvest that's happening. And that's really where we are trying to explore in British Columbia on how do we bring that into our sector. And what I'm talking about is, you know, the first start of added value is when you have a saw log facility and you have the sawdust and the chips left over, it goes to the pulp. So pulp is an added value for the fiber that came from those trees. We now have a strong pellet sector in British Columbia, which is also providing that. We also have cross-laminated timber production and the Office of the Mass Timber Implementation in our province, in our government, and their focus is to be able to promote and increase the use of cross-laminated timber, mass timber products using the fibers that we have in British Columbia, and that again is a form of value added. But we can also push it further. We've got residual materials out there that we don't typically use in British Columbia. And that can, if we can figure out the way to utilize that and move the dial with regards to that fiber, we can go into the engineered wood products aspect, the biochemicals, the biomaterials, the bioplastics opportunity with the right investment in the right place. So we're really looking at key activities in the new Provincial Climate Action Plan, and that's with regards to supporting integrated bioproduct manufacturing and regional biohubs, where fiber can become available for those different uses in those different products. Next slide. As I've mentioned, in British Columbia and across Canada, Indigenous nations and reconciliation is very important. We have a very small program in British Columbia that's looking with Indigenous nations on the bioeconomy programs. And these are non-traditional products used from the forest. We have collaboratively identified and pursued forest bioeconomy projects with Indigenous partners across BC by utilizing biomass and residuals from conventional harvesting for novel high-value applications. And the program supports forest sector transformation with full participation of Indigenous nations. These are not large scale at this point in time, and they're not using a lot of fiber at this point in time, but they are an example of where we can go with the forest bioeconomy. Things like big leaf maple syrup. We all love maple syrup from Eastern Canada, but we also have maple trees in British Columbia, and we're looking at the development of big leaf maple syrup. We're looking at essential oils from coniferous needles, non-woven medical textiles produced from cedar, and biochemicals such as tannins extracted from the barks. So these are a bit, obviously in its infancy stage and just in small numbers, but it does open the mind a little bit as to where we can grow a small economy that's very important for a province like British Columbia with their Indigenous partners, and bring some more value into what the forests offer without adding additive extractions. Next slide. So managing for forest carbon in British Columbia, we've been lucky enough to join in collaboration with the federal government in British Columbia around our forest carbon initiative. And what that has worked with, and we work very closely with Werner Kurz, one of our next speakers. What it's developed is really an opportunity to study and learn and find the science behind and the accounting behind doing opportunity work out in the forest as we do normally with forest management, but do it in a carbon-friendly way. And we're looking to increase investments in silviculture and forest management that provide carbon sequestration, decrease greenhouse gas emissions, increase employment opportunities in rural areas for Indigenous communities, and wildfire risk reduction. We are updating the Forest Carbon Offset Protocol 2.0 to provide a framework for the province, and that may create an opportunity for some revenues to also come into the province. That would be incremental initiatives, things that we do in forest management, like planting differently, doing our activities differently on the land base, looking at the health of our forests and focusing on that so we have healthy, resilient, fast-growing trees that support greenhouse gas sequestration. Next slide. One of those activities in British Columbia that is getting a bit of focus on right now is in our intentions paper, and it is minimizing slash pile burning. So in British Columbia, we have a practice of the residuals from harvest operations for fire mitigation. It's a requirement to either use the slash or burn up the slash piles like you see. And by finding opportunities and the willingness and the right economic situations, we are able to move some of the materials in a pile like this into a manufacturing facility and be able to reduce air pollution because we're not burning it up, and greenhouse gas emissions, obviously, and foster some economic opportunities. We've had a program going on for a number of years now that has been quite successful. And we will continue on this vein and making additional progress in this way to minimize and or eliminate slash pile burning. Next slide. So climate adapted forests. British Columbia has done an enormous amount of work on this. And again, it's thinking about doing things differently for your reforestation. So we have stocking standards, which is, the density of the planting of the trees. And we're looking at changing those. We're looking at climate-based seed transfer, making sure that the seed we're using for our reforestation activities are in alignment with our projections of the climate changes of the ecosystems effects that we are seeing in British Columbia. That's being projected by our climate scientists. We're also looking at species selection, changing the zones and altering them to reflect the projections that we're seeing of the ecosystem changes. We're updating our ecosystem mapping with regards to the changes that we're seeing from the climate change impacts. And so we may be increasing planting density or maybe altering planting density. And that is, of course, linked to wildfire mitigation and what the right solutions are for that, given that we know that the wildfire seasons that we've been having, there's a good chance that they will continue in that vein. So we need to prepare, adapt, and change what we're doing. And all of that is based on vulnerability assessments and carbon modeling as part of our forest landscape planning, which we haven't done before, but we are doing now. Next slide. What's next in modernization? Our forest management legislation, the Forest and Range Practices Act, is being revamped to be able to look, rather than site-by-site forest management, more into a landscape planning initiative to be able to see continuity of actions and regimes put across a land base. And so we're introducing a forest landscape planning framework to clarify forest management objectives. Next slide. So what's next? Basically everything that I've said, just continuing on and making it better. We're advancing the bioeconomy. We're looking at BC's forests as carbon sinks and how can we manage that the best way. Minimizing slash pile burning, creating climate change informed adaptation forest management, increasing Indigenous partnership, and shifting from high volume to high value production. Next slide. If you want to learn more, there's the websites for Clean BC, Modernizing Forestry, and Climate Preparedness and Adaptation Strategy. And I thank you for listening.
Thank you very much, Diane. I'm now going to ask Werner to give his presentation.
One second. There we go. Can you see the presentation now? Okay, so thank you, Oscar and colleagues, for the invitation to give this presentation today. Thank you to the organizers, and good day to the participants. Thank you, Diane, for setting the stage so beautifully. I want to pick up from where she left and speak about the forest sector contributions in Canada to net zero pathways and highlight both the risks and the opportunities. As we all understand, the Intergovernmental Panel on Climate Change, or IPCC, released in 2018 a report on global warming and the efforts that would be required to keep us to well below 2 degrees centigrade. And what they identified is that not only do we need rapid and far-reaching transformations in all sectors, but we also have to have net negative emissions. In fact, what they pointed out that in order to halt warming at any level, we have to have net negative emissions. And if we want to have warming halted by 2050 to below 2 degrees, then we need to have net negative emissions by 2050, or at least net zero emissions. What that means for humanity is that we need to find ways to both reduce fossil fuel emissions and at the same time increase land sector carbon sinks. The problem that we face is that our forests are also increasingly and detrimentally impacted by climate change. Prior to COP, nations submitted their nationally determined contributions, and the United Nations Framework Convention has just, prior to COP, released a report in which they summarized all the submissions that were made. And as you can see in this graph, very clearly the NDCs, or nationally determined contributions, fall far short of the required emissions to keep us below 2 degrees centigrade. And these are the commitments. They also need to be achieved. So the challenge is enormous. In Canada, we have developed and implemented over the last 20 years a national forest carbon monitoring, accounting, and reporting system. As both Oscar and Diane identified, policy decisions need to be based on rigorous understanding and analyses of the consequences of our activities. And so this system was designed to not only meet the reporting requirements to the United Nations Framework Convention and others, but also to allow us to make projections and to analyze the outcomes of mitigation and adaptation strategies relative to business as usual trajectories, and to quantify whether a proposed mitigation action is indeed climate effective and over what time frame. This system was designed to report on the anthropogenic emissions and removals, and that means under the IPCC guidance, we need to focus on the so-called managed land, because it is understood that in the managed land, carbon dynamics and greenhouse gas emissions are predominantly influenced by anthropogenic activities. I'll come back to that in a second. Canada defines 226 million hectares of forest land as managed. You can see that in this map here as the southern darker areas. There are northern boundaries defined by areas of fire suppression or insect suppression. And managed forests are not only those that are managed for timber, they can be managed for other purposes, biodiversity, national parks, et cetera, are also included in this. In addition, Canada has another 121 million hectares of unmanaged forests in the north, and for those we only report and track land use changes. We have central to the system a carbon budget model that is used around the world. It was developed over the last 31 years by our team. We use very detailed measurements of forests. Over 3 million records describe the forest conditions for Canada. We have over 100,000 growth curves that were developed from permanent and temporary sample plots, so heavily measurement-based. And these measurements were taken over the past decades. We combine these inventory and growth and yield data with data from natural disturbances like wildfires and insects, management activity data such as harvesting and slash pile burning, as well as data on land use changes such as the conversion of forest to non-forest land uses and afforestation. We combine that with ecological modeling parameters and climate data to then generate estimates of emissions and removals. Here's an example of a national summary for the period 1990 to 2019. This is for forest land remaining forest land, and this graph does not include the emissions from harvested wood products. I'll come back to that later. The x-axis shows the years, and the bars show you the area affected with a right scale by major disturbances in forest management activities. The line shows you the greenhouse gas balance for forest land remaining forest land, and it shows the sinks as negative values and sources as positive values. What you can see is very large interannual variability driven by large fire events, a long-term trend driven to some extent by large outbreaks of insects, in particular the mountain pine beetle in British Columbia. And within this huge interannual variability and an overall trend towards a diminishing sink and an increasing source. We can anticipate a continuation of the current trend. We do not yet have the analyses conducted for 2020 and 2021, but we know that 2020 was a very low fire year across Canada, and 2021 was the worst year on record for Canada as a whole. We have 1.8 times the area burned in the previous record year of 2015. So we can be fairly certain that 2020 will be a small sink or maybe a small source, while 2021 will probably be the largest source on record. Not good if what we're trying to achieve is net zero emissions. So one of the things that we want to better understand is what is the anthropogenic component and what is the natural disturbance component in this. And so we develop methodologies that are published in the Canadian Journal of Forest Research to partition the blue line into two components, that which is the anthropogenic component and that which we consider to be predominantly natural disturbances. And what we see now is both of them still have a trend of declining sinks or increasing sources. We see the very clear and very large interannual variability associated with natural disturbances and a trend in the anthropogenic component that we can now better quantify and explore how mitigation efforts will influence that. But before I go there, let me introduce the harvested wood products emissions. So when we harvest wood, Canada is responsible for the reporting of the emissions associated with the wood use. So if we turn pellets into bioenergy, we report those emissions. If we put wood into long-term storage, we report the emissions when and where they occur. And so those emissions are, for Canada, estimated at about 140 million tons, give or take. And when we add these to the sinks in the forests, we get this green line here, which gives us the current net balance of emissions and removals. And what we see is that, again, a trend of a declining sink associated with two things: increasing harvest rates and insects of low impact, less than 20% mortality, because insects that cause more mortality are in the natural disturbance component. We see clearly an increase in the sink as harvest rates were diminished with the global recession around 2009, and then a small increase again. So with this tool now available to us, we can proceed and better quantify what the mitigation outcomes will be and what changes and disturbances might be in the future. And the big question that we are trying to address here when we ask the question of risk or opportunities is whether through our mitigation activities that we are proposing to implement, we will bend this curve downwards and increase sinks at a rate that is greater than climate change will force increases in emissions due to wildfires, disturbances, tree mortality, and drought. So let's look at what we know about natural climate solutions and ways in which we can enhance forest carbon sinks. A recent national study led by Nature Canada looked at natural climate solutions. 3 of the 24 pathways were analyzed by our team and involved the forest sector. These are restoration of forest cover, improved forest management, and avoided forest conversion. Just very briefly, we don't have time to go into all of the details. The highlights are that restoration of forest cover, which means we plant forests where they have naturally, historically occurred, can make an annual contribution that is relatively small by 2030, certainly well below 5 megatons, and even smaller if we introduce changes in albedo. But these are greatly increasing. These contributions are greatly increasing over time. Improving forest management, such as reducing old growth harvest, enhancing tree regeneration rates after harvest, and better use of wood along the lines of what Diane just explained, would bring an annual contribution nationally by 2030 of less than 10 megatons CO2e, again with an increasing trend over time. And avoided forest conversion, so that's not converting forest into cropland or settlements, again, would give us a relatively quick benefit in the short term. This was only implemented to 2030, but again, the magnitude of the changes is in the order of 5 megatons or so. So remember those numbers, 5, 10, 5, for things that we can do. So let's look at another question, and that is, what happens to the wood when we harvest it? And how and where we use the wood matters greatly, as I will show, based on a study that our postdoc Sheng Ji, who is with the Pacific Institute for Climate Solutions Wildfire and Carbon Project, has just published for British Columbia. Without going into all of the details, what we basically asked is, if we assume a base case utilization of wood products from British Columbia from 2016 to 2050, here's the cumulative emissions on the harvested wood product side. This is not accounting for the offsets that are occurring due to forest regrowth, and it's not including substitution benefits. We then said, okay, so hypothetically speaking, and this is only possible theoretically, of course, but what if all of the wood that we harvested in British Columbia went into the construction sector, mass timber, panels, etc., and we would see a very large reduction in emissions associated with a long-term storage of wood products. If, on the other hand, again, only theoretically possible, we converted all wood that is harvested in British Columbia into biofuels, we would not only see very large increases in the emissions, not accounting for the offsetting benefits of avoiding the forest fuel emission. But the depressing part is that even if we did all this, the amount of biofuels that we could produce would just barely meet the demands in British Columbia alone. And that is not, that's a relatively small province with a very large forest sector. We then also looked at some more realistic examples and, just in summary, looking at this one here, which focuses more on the domestic market of wood uses, and we would get, somewhere around 4 megatons of CO2e per year on average cumulatively to 2050. So again, a relatively small number. But what we have demonstrated with this, and Diane again, has picked up in her policy some of these issues, is that when we have opportunities to make decisions about how we use wood, two indicators are of great importance. One is how long will the carbon that is retained in the wood, and 50% of the dry weight of wood is carbon, how long will that carbon be retained out of the atmosphere in the products, and what, when we use this product, will be the displacement factor? Can we use wood products instead of emissions-intensive materials like steel and concrete? And what these analyses all show is that bioenergy has a very short carbon retention time, has a range of displacement factors that depend on what kind of energy we're substituting for. Obviously, in British Columbia, substituting electricity, where most of our electricity comes from hydro, is not very climate effective. On the other hand, if we put material into strong structural building products, we have much greater climate benefits. And the last study that I want to highlight briefly, this is not yet published, is work that we're doing in collaboration with Parks Canada to try to ask the question, well, what about forest conservation? What if we stop harvesting? And in Canada, we have a nice experiment, started back in 1850 or so, when we started setting up a whole series of national parks. And so collaborating with my colleague Tara Sharma from Parks Canada, she has led this study. We looked at the carbon balance of 31 national parks, the ones with the black labels down here. The total area is about 5.6 million hectares, and we ran this with our advanced generic spatially explicit carbon budget model at 30-meter resolution. And so highlighting the results, in the 1990s, all of these parks were annual and cumulative carbon sinks. However, climate change impacts started to increase in the 2000s, and now we have years where the parks are gains and others where there are losses, but with no cumulative gains. From the 2010s to 2020, the last decade, we've seen large increases in losses due to insects and wildfires, so that by 2020, only a small cumulative net gain remained, and the greenhouse gas balance, by including CO2 and methane, non-CO2 and methane and N2O emissions, became a net cumulative source. In other words, a long-term strategy of conserving forests in national parks has not resulted in a net increase in carbon sinks due to the climate change impacts. These results are dominated by 4 large Western parks, and particularly Wood Buffalo National Park, that has strongly been affected by wildfires. But what this means for us is that when the goal is to increase forest sinks, a conservation-based mitigation strategy needs to seriously consider the risks from wildfire, insects, and climate change, as well as other disturbances, because ignoring these may very well result in outcomes as we observe in the national parks, which were, of course, not created to generate carbon sinks, but for other purposes. But carbon sinks, they have not been over the last 31 years. So wildfires are a really big issue. Diane already mentioned the 2017 and 18 fires. What she didn't mention is just the magnitude of the emissions. The fires, these 2 fire years in British Columbia released 3 times the emissions in each year from all of the sectors of British Columbia combined, and 2021 will be another twice the emissions from all of the sectors combined. Nationally, over the last 5 years of the reporting period, the wildfire emissions are in the order of 182 megatons of CO2 per year on average. So these are very large emissions. And what this highlights is that when it comes to the impacts on our greenhouse gas balance from mitigation versus disturbance impacts, our analyses have consistently shown that the disturbance impacts can exceed mitigation benefits by an order of magnitude or more. This is further accentuated by the fact that carbon uptake, such as through forest regrowth, is always a slow process, while fire emissions are rapid. And so, the two photographs, perhaps an over dramatization, but still the point I'm trying to make is that through mitigation actions, not only do we have to spend money to make these happen in the first place, but we will at best be able to affect a small proportion of our forests every year. While at the same time, climate change, and the train has left the station, these things are coming, will affect all of the forests every year. So what we then need to ask ourselves, well, if this is the case, is there a way in which we can perhaps reduce the risk for future wildfire emissions? And in last year, we started with the Pacific Institute for Climate Solutions in collaboration with the Canadian Forest Service, US Forest Service, UBC, Parks Canada, and the province of British Columbia, a new project where we're asking the question whether we can combine some of these objectives that Diane mentioned with those of maximizing carbon sinks and minimizing wildfire emissions. So specifically, are there things that we can do that would help us reduce wildfire emissions, enhance carbon sinks, and at the same time create bioeconomic opportunities in British Columbia, whether that is through novel wood products, through greater use of manufactured wood or mass timber in buildings. And so this project is on the way, and we're doing lots of analyses right now to try to answer these questions. So before I close, let me just end on a positive note. Should we pursue natural climate solutions? And the answer unequivocally is yes, we must. The IPCC has identified that every ton matters, every year matters, and every degree matters. So whatever we can do, we can't throw in the towel. We have to turn our attention to ways in which we may have, through our mitigation activities in the forest sector, the greatest mitigation opportunities. And as speakers before me pointed out, that requires that we have rigorous analytical capabilities to help us develop mitigation pathways that are climate effective, but that also anticipate climate change impacts. And we need to have very realistic expectations of the magnitude and the timing of when these mitigation benefits can be achieved. So in closing, despite climate change impacts, Canada's forest sector offers opportunities to enhance sinks and contribute to net negative emissions. However, climate change impacts are projected to further increase, and in particular, future wildfire and the associated emissions are projected to increase. All the climate scientists are in agreement on that. So we need to act now to reduce future wildfire emissions through mitigation and adaptation activities, but most importantly, we must not let natural climate solutions become an excuse to not reduce fossil fuel emissions. Fossil fuel emissions must be reduced rapidly because land sector sinks alone cannot solve the climate problem. If anybody is interested, here are additional publications and my contact information. And with that, in 20 minutes, I will hand this back to Oscar and the next presenter. Thank you very much for your attention.
Thank you very much, Werner. So I'm going to turn it over to Ward now.
That's great. Thank you so much, Oscar. Thank you to the organizers for bringing us all together, and thank you to all of you for attending today. I'm just going to share my screen. As I do so, I want to say I sit here at Queen's University, and Queen's University is on the traditional territories of the Haudenosaunee and the Anishinaabe peoples. It is a privilege to be able to work here and to enjoy this land and to get things done. As we talk about solutions for forests, we have to remember that those forests do sit on traditional territories, hereditary territories, right across the country. I think it's an important thing for us to keep in mind because a primary stakeholder in any discussions will be the Indigenous peoples of Canada and how we move forward. And I was really interested to hear from Diane what's happening in BC and some of the progress that's being made there on that front. I'm going to be talking primarily about forest products and the policies and the plans that will be required to move these forward as we go towards a net zero future. I'm going to try to build on some of what Werner's been talking about. You know, a big takeaway for me from Werner's talk is that we can do some things with harvested wood products that are going to help this overall carbon budget, but are also going to show us maybe better ways to use material and better ways to work as we go forward. So the first thing that I'm going to start with, and I want to thank some of my colleagues at the Canadian Forest Service, particularly Saeed Gafgazi, a former colleague there who helped put this together. This is a Sankey diagram that shows you how forest biomass moves through different products in the forest cascade. And a couple things about this slide that I want you to keep in mind. First of all, this is older data. I do not have an updated slide to show you what things look like in, let's say, 2020. And there would be some changes to the proportions that have flowed into different things. You can see down the right-hand side of the slide, there's a list of a lot of different products: lumber, OSB, particle board, etc. One way to think of it is that the more durable products are at the top of the Sankey diagram, and the less durable products, the paper and paper products, are at the bottom of the Sankey diagram. A couple things that I take away when I look at these diagrams is, number one, although forests and wood products form part of a circular economy, the way we use wood products is not really circular, or not too circular yet. There's probably a lot that we can do in order to improve this. The exception to that is at the bottom of the slide, where we see the yellow arrows going into the pink arrows. These are the paper curves. And what we do see there is a lot of other material, the red line coming in. That is recycled material that's being brought back into the industrial processes as feedstock. So this represents the circular component of the forest economy that, you know, has been very successful, and we can talk about some of the lessons that we draw from it. A couple other things that I take from this. Number one, it was pointed out by my colleague Werner that we don't really see black liquor on this slide. It's there probably, but it is buried or subsumed inside of the pulp and paper curves, or the pulp and paper arrows. So we're not seeing that energy contribution, combusting a portion of biomass in order to drive processes. That self-energy generation is actually really critical for our sector. It really helps us in terms of our overall carbon balance. The other thing is that while most of the arrows on here are shown in oven dry metric tons, there are a couple that are shown in petajoules around bioenergy. So do keep that in mind if you're looking at this slide. The energy piece is actually a very small arrow, and I think that's why it's been changed. So you've seen how the forest sector sort of breaks down by products, and you have a sense now of those proportions. Let's go to the next slide, where I try to put it into that sort of circular thinking or circular economy. And I've purposely chosen to put this on an axis that's actually very large. It's a circle that's 480 years long, which seems like an awfully long time, but there's a reason behind my thinking here. At the very top, where it says 0, that's where we start with atmospheric carbon, atmospheric CO2, that is slowly taken up by forest biomass. And remember, this is an illustrative example. Trees in Canada grow at different rates in different places, and those rates are changing as climate change proceeds. I've just taken a very arbitrary 100 years, which is not unusual in a boreal forest or in some of our northern forests, as a kind of a growth cycle to reach maturity. This would not work if we were talking about the rainforests on Vancouver Island or on the coast of BC. And it would not work if we were talking about the deciduous forests in the southern parts of Ontario and Quebec. So keep that in mind. After harvest, which in this illustrative example happens at year 100, a portion of material is going to go into the paper and paperboard products. And that is a circular piece where there is a component that is recycled every year, shown in purple. It's a diminishing sort of a cycle. And that cycle can take anywhere from months to years to decades, rarely centuries. You know, think of how much paper makes it from century to century. It's a very, very, very small slice. The brown slice represents the materials that are going into construction, and the red slice represent materials that are going into furniture and fittings, which is a slightly different pathway. The construction materials do last for a long time. The half-life that we're looking at here is roughly on the order of 70 to 80 years. And there are different estimates on just how long construction materials stay in service. And so it peters out over that 250 or 300-year horizon. The biomass slowly will leave service and be disposed of either through landfilling or through combustion, or even through rot, which leads to emissions. A few other pieces here. There are losses that are going into landfills, and landfills, are in a way long-term storage of carbon. We don't have vast volumes of landfills, so it's not really an option that's going to satisfy all of our requirements, but there are ways in which we can minimize those curves or maximize those curves depending on our goals. There's also portions that go into energy, and those energy arrows right now are relatively small. Most of the energy comes off early in the production of these materials, because most of the bioenergy that we're grabbing is not coming from waste wood or waste materials. It's coming from residues from production or residues from harvest. So keep this in mind, because I'm going to come back to the slide towards the end. Let's talk about some of the barriers and the solutions to those barriers that could help us increase the whole push towards net zero. So the first big thing, the wood that we use in construction, whether it's lumber or whether it's panel products or any of those sorts of structural materials, they're not designed to be recycled. Just straight up, they're really not, either in the way that they're made or the way that they're used, designed to be taken out and to be used again. They're very difficult to recover and to reuse. The cost of recovery is very high, and we're only now starting to see commercial efforts happening in Canada to grab that material and to put it into use. There are ways around that. The pulp and paper sector is now a leader in recycling and has been since the 1980s. But to get there, a lot of changes had to happen to the way that we actually made and used paper. Those of us that kind of participated in that transformation may remember the days when inks were very difficult to deal with, for instance, or binders, the glues that were used to hold papers and magazines together were very difficult to deal with. And so what happened is that we changed the types of inks and we changed the types of binders. And we were able, through those types of process or application changes, to increase the ability of this material to be recycled and to be reused. You need policy to support that. You need policies that are going to either mandate the amount of percent or the percentage of recycled content. You're going to need guidelines for waste disposal. And of course, you need to plan for the flow of materials through your system. If you're going to reduce the amount of virgin fiber that you need, you're going to have to plan for either what you're going to do with the remainder or how you're going to access the amounts that you need in order to put this into play. Coupled with this first barrier is the fact that construction practices will need to change. And I say this because in order to introduce circularity to the forest product sector, particularly around these solid bioproducts, we will have to think about how they're being used, the way in which they're being applied. And if you think about a house today, and here's a photograph of a tear down in Vancouver that was ripped into small shreds in order to allow the production of a much bigger building. You can see just how difficult it is to extract lumber, extract material from these construction techniques. We also know that we don't just build single family, two-story homes in Canada. In fact, predominantly we're moving towards tall buildings, and we're moving towards multi-unit, multi-story construction. And getting wood into that kind of construction, it's possible. We're seeing it. There are examples across the country. but it's a big change to the way that we do things. It's a big change to our practice. So it's not just the building codes. You know, a lot of people say if we could just address the building codes, things would change. It's actually thinking about all the carpenters and then all of the other trades. How do we do the piping and the electrical work? How do we do insulation? Are we going to go to factory built modular panels that can be clicked together? Are we going to go to factory built floors that can be lifted and put into place? All of these things need to be worked out. And so it's a much more complicated problem than it looks like on the surface to try to drive increased use of these materials across the landscape. Policy goals can conflict. And this, I think, is one of the hardest things that we have to deal with forest products and how we're going to contribute to a net zero future. So for many years, those of us that have worked in this area, a lot of the policy and a lot of our goals have been dominated by demand for bioenergy. And the demand for bioenergy has been driven by the fact that, you know, the majority of our emissions come from fossil fuels. We're looking for renewable fuels that can offset those emissions. Bioenergy is seen as one of those fuels. And as a system, that's fine. You can just look at the trade-off between one and the other, and you might come up with a conclusion that, yes, it makes sense. We should be putting more bioenergy into the mix. But what we've discovered over the years, and what has become increasingly true, is that we're not taking all of the impacts of making these transformations into account. So, you know, pushes towards biofuels to replace liquid fossil fuels, whether it's gasoline or diesel or other fuels that are out there, not only need to be compared against the fossil equivalent, so the biofuel needs to be compared against the fossil equivalent, but you have to look at what the impact is on the carbon cycle for the forest. And Werner's done a good job of laying that piece of the puzzle out. The more we look at the carbon balance of forests and forest products, the more we understand that putting biomass into bioenergy without getting other uses of these products doesn't really make that much sense. And so now we're met with a challenge. We need to, you know, find ways to achieve these carbon reductions. We need to find pathways to net zero. We need tools to help guide us through this. We need tools that planners can use to make these decisions. They need to be clear, they need to be understandable, and they need to reflect the best science. Life cycle assessment is one of those tools, and I do a lot of work with life cycle assessment. The challenge is that it isn't really a planning tool. It's a scientific method. It's a scientific method that needs to be applied under very, very strict conditions, and comparing between life cycle assessments is actually really difficult. So we need to evolve tools. We need a tool, I think, that is based on life cycle assessment, but which takes us in another direction. And then finally, we need penalties. We don't really have penalties or benefits for people that are making good decisions about what they're doing with their carbon. Yes, we do have carbon pricing. You know, we have a certain amount per ton, and that amount is going up, and it's going up fast. But if you ask a homeowner whether a carbon tax is going to make a difference as to whether they tear down their structure or build a new structure, the answer will be no, because it will be a very, very small amount compared to the value of the home or the value of the product. There is right now no benefit to long-term sequestration. There is no benefit other than avoiding that tax that you pay at the point of emission. And if the value of your product is high enough, the tax becomes less meaningful. So we need carbon taxes, but they need to be differential. They need to apply at different rates to different types of products. And that is maybe where we're starting to go with clean fuel standards and the application of them. We also need to think about carbon equity. So how do we recognize the value of the long-term storage? How do we deliver more value the longer you can store something? So we started with this sort of a graph. If we could apply all that we're learning, we can really dramatically increase the amount of time that carbon is spending in products doing useful jobs. And carbon doing useful jobs and useful products is far better than carbon in the atmosphere. And it's far better than carbon just going into landfills or going into some sort of long-term storage where there is no benefit to be derived. You know, this is what would happen if we could kind of double the application of construction materials, if you could triple or quadruple it, and if you could ensure that what you get off of that as material comes out of application is energy, then you start to meet multiple goals of a net zero bioeconomy. So the key takeaways, and I know I'm just at my time here, the circular economy that we're talking about here can maximize the availability of fiber. You know, single fibers do a lot of things over the lifetime of application. And I think it's one of the few ways that we can make limited resources available to a rapidly increasing and rapidly affluent society. We need a very extensive policy suite to make this happen. And we need to know what the policy goal is. If the only goal is to bring down greenhouse gas emissions, a lot of the potential of a circular bioeconomy becomes too far away to be meaningful today. But if our goal is to come up with a more sustainable way of living, then suddenly the circular bioeconomy becomes a much, much more powerful tool in our toolbox. And the last thing, and I'll just throw this in because I know somebody's going to ask, the international flavor of what we do adds challenges to our decision making. It's not just about what we're making for our use here in Canada. We have to think about what our partners are using, and that's challenged by the fact that there are a lot of different ways to build out there and a lot of different ways to utilize these materials. So I'm going to stop there. I'll hand back to you, Oscar.
Thank you very much, Warren. That's a very thought-provoking presentation, and we're now going to move into the question and answer period. So I'm going to ask Robert to table the first question.
Thank you, Oscar. So the first question from Rick is, if the takeaway message is to ensure the future economic development, then what measures have the government implemented to address cost competitiveness, given BC is the highest cost producer in North America? For example, wood waste would be used if the cost of production was less than its value.
So thank you for that question, Robert. I'm going to ask Diane to respond to that.
Yeah, thank you. Good question, Rick. And good to see you on this forum. It's been a while. So, you know, when we look at the use of residual wood from harvesting operations, what we're looking at is how do we create a value proposition for the use of that wood? And part of it is how we process in British Columbia, but part of it is also what are those higher value and additional or additionality products that we can get from the tree that would allow us to bring that wood in. So yes, you're correct. It's a high cost value proposition in British Columbia for our dimensional lumber, and certainly the products from that go to pulp and pellets. But when we're looking at an opportunity of that residual, those slash piles and utilization of that, it's not, you know, it's not going to be going into those kind of conventional products. It's going to be going into those, you know, at the top of the pyramid, into those bio product materials, propositions and plastics and or chemicals that allow us to further the value chain. So you're getting, you know, a portion of the tree for the dimensional lumber, a portion of that goes into pulp and paper, but another portion of that tree gets utilized into these new products that are up and coming globally, and there's a need for that. Some of that's, you know, we all know the issues with our climate and the impacts of plastics in our oceans and plastics around the world. Well, wouldn't it be a great thing if we were able to use biomass that currently isn't used and burnt up in a slash pile to be doing that? Now, that's a lofty vision. I understand that it's going to take us time to get there. But, you know, if we don't have lofty visions, we don't think about those things.
Thank you, Diane. Robert, next question.
Yes, another one from early in the session from Peter. It is not either or for the bioenergy and structural forest products, and forecasts like that from the Troche Energy Institute puts bioenergy with carbon capture and storage as essential components of reaching net zero. And BC is not an isolated jurisdiction and can sell excess electricity to burning jurisdictions like Alberta and Oregon. And that may be
Thank you for the question. I'm going to ask Werner to respond to that.
Yeah, that's a good question, and really it would require a very complex answer. Starting with the last point, there is not a lot of electricity connectivity between British Columbia and Alberta. The electricity lines go south, so we're feeding into southern markets, not into Alberta. That's a structural problem that certainly could be addressed, and it might help use some of BC's electricity to reduce coal-fired power plant emissions in Alberta. But those electricity lines don't exist. Carbon capture and storage is indeed the holy grail when it is combined with biomass energy production. But the reality is that we have virtually no such capacity anywhere in the world. The Drax power plant in the UK is an exception. And yes, people have been striving towards that for a long time, but it's not a real solution in the long term because it's very energy intensive. And for people in British Columbia to understand, or elsewhere in North America, if we ship pellets to Europe to feed their power plants and their carbon capture and storage facilities, we still are responsible for reporting the emissions under the international guidelines. And so we would be far better off, and that was part of the, where we use wood matters study. We would be far better off if we use the pellets that we produce either as feedstock for more long-lived products and bioplastics, as Diane indicated, or if we just use them in British Columbia to produce, energy that offsets our own emissions rather than those abroad. And I'll leave it at that. This is a long discussion otherwise.
Well, thank you very much, Werner. So, Robert, I think we have time for one more question.
Yeah, so from Yongay, we learned from some research that trees' carbon absorption rate declines with age, and too old trees not only absorb less CO2, but also decay and create some insect problems. Could you please comment on this and share some thoughts on the rationale of old growth harvest deferral?
So I'm going to ask Warren to give an initial response, but I'll also ask Werner to give a follow-up response.
I think it's a great question. Yes, in certain cases, you're going to see trees lose their ability to absorb a lot of new carbon, or forests is probably a more accurate way to describe it, to take up a lot of new carbon. And in fact, you could get into a position where they become sources rather than sinks. And I think that Werner made that point really clearly. From my perspective, if your goal is to sequester carbon, this is the time to take some of that wood out of the trees and put it into long-term applications. And long-term applications are going to do a better job of sequestering that carbon and open up areas of the forest that can regrow. But it has to be balanced against a lot of other needs, and that's, I think, what Werner was getting at in his presentation.
Yeah, just very briefly, first of all, yes, the carbon uptake rate, the rate at which additional carbon is stored in ecosystems is highly age dependent. It's also ecosystem dependent. And yes, old growth forests can be carbon neutral or small carbon sources or small carbon sinks. It depends very much on the ecosystem type that you're dealing with. And of course, we conserve old growth forests not only for their carbon sequestration capabilities, but for many other reasons. What is important in the point that Warren made, and some people argue, well, we got to cut down all these old growth forests and replace them with fast growing plantations. Yeah, that's a real problem because the wood that we take out of the old growth forests is going to be released. Some of that carbon is going to be released into the atmosphere very quickly. And so a strategy that heavily emphasizes conversion of old growth forests into second growth forests will have short-term carbon emissions that will take years to take up again. And so that's why these kind of analytical tools are so important, so that we can differentiate when it might be a good idea to convert an old and over mature forest into a young, actively growing plantation, and when we might be better off just leaving that large carbon stock in place, even if it is a small carbon sink or none, keep it in place and protect it for values other than its carbon sink capability.
So thank you. So given the time, I'm going to try to bring the formal part of this webinar to a close. So I'm going to ask each of the presenters to give a quick closing comment. I'll start with Warren, and then Werner, and then Diane, and then just so that you all know, we are here for another 15 minutes to answer any further queries from our audience. So Warren.
Thanks, Oscar. So I think what I would emphasize is that it's really important to know what our overarching goal is. And a lot of the tension in some of these discussions comes from the fact that quick reduction of carbon emissions may not be the same or lead to the same outcomes as a long-term plan to build carbon sequestration in both forests and harvested wood products. Because it will take a long time to build these stocks up and to introduce these new practices. So that tension is what I think we need to focus on, and how do we untangle it, and how do we make decisions for the best of the whole country.
Werner?
Yeah, as a scientist who spent 30+ years working in this field, I think the single most important thing is that we continue to be informing our policy decisions by the best and most rigorous scientific capabilities that are available. There are so many examples where solutions are being proposed that in effect are not climate effective or are not climate effective for 20 years. If the worst thing we can do is be well-intended and make the situation worse. And there are examples of that. So what we need to do is continue to inform our stakeholder community, including First Nations, NGOs, and industry, about the consequences of the proposed actions so that we can do things that are in effect climate effective.
Thank you for that. Diane?
Thank you. I think, from my perspective as a chief forester for a province that's very much forestry dependent, and looking at the impacts that we can have, whether it be source or sink, what always comes back to me from the work that Werner and others do, and the work that Warren and others do, is that one size doesn't fit all. There's no silver bullet. We need a myriad of variability out there. And, there's just so many inputs and outputs. And as we do more and as we learn more, we'll be able to refine those. But in the long run, we need that variability. And I think, the most important thing from a chief forester perspective is a healthy forest, whether they be old, young, or immature or mature. We need healthy forests, and that helps us in the global challenge.
Well, thank you very much, Diane. So I now have the distinct pleasure of sort of bringing this the formal part of this webinar to a close. So in doing so, I want to first of all thank the three presenters, Diane, Werner, and Warren, for really excellent presentations. I know that a lot of the work went into the presentations, and I know you all were very respectful of the time commitment, so that is really appreciated. I also want to extend a special appreciation to the members of the organizing committee. This organizing committee has been working at this for about 4 months. So this is probably the best planned webinar in the history of the Academy. But special thank you to Bruno Gagnon and Tony Lepriere at the Canadian Forest Service, to Patrick Lavoie at FPInnovations, and to Nicole Foyer. And I was also a member of the organizing committee. And finally, I would like to also extend, on behalf of all of us, special thanks to the Academy, Robert Crawhall, Anne-Marie Wen, and Emmanuel Nicolo for organizing all the logistics and for getting the invitations out to a very, very large audience. And then finally, thank you to all of you who have attended and this webinar and for your interest and participation in the webinar. So that closes the formal part of the webinar. As I mentioned at the outset, we will continue on with Q&A for another 15 minutes. So I'm going to go back to Robert and ask him for the next question.
Okay, thanks, Oscar. Let me just move through here. So there's a question here, and I'm going to select sort of through the list because the questions really did track the presentations, and I want to make sure we get through a variety of them. There is a question here that says, what is being done to ensure the viability of these plans in terms of safety and on-the-ground feasibilities? Roads are often not conducive to most vehicles, or at least not all forest and in block roads. There is a driver shortage as well, and highway training doesn't transfer to resource roads. So I think there's a general question here about the pragmatic infrastructure around the changing forest usage.
So I'm going to ask, thank you for that, Robert. I'm going to ask Diane to respond to that because I'm sure she's in the middle of all of this.
So, I find the question a bit confusing in the sense of, health and safety. Where my mind goes, rightfully or wrongly, I'm trying to interpret what the question is, when we talk about energy saving, maybe electric vehicles for resource vehicles or self-driving trucks because of the driver shortage and that kind of thing. How do we make sure that we've got safety precautions in place to do that? And, rest assured, just like highway safety and protocols, expansive testing occurs before any of these changes are allowed onto the resource roads, just like they are with Ministry of Transportation. And most of our resource roads link up to public roads. So we have to meet the same standards. So if we're looking at alternatives, then that is what's been done. We just follow the same testing. But it looks like Werner can answer this as well.
No, I have nothing to add. I think you got it.
Okay, Robert, next question.
There was also a question regarding coniferous and deciduous forests and whether what we've been talking about was equally applicable. I think Werner had some thoughts on that.
Okay, yeah, so I'm going to ask Werner to respond to that.
Yeah, thank you. That is a really good question. So historically, because of the higher economic value, there has been a lot of attention paid to coniferous forests and coniferous tree species. And in fact, deciduous species have been actively discouraged through silvicultural activities, through planting, through thinning, through herbicide treatments and other measures. What we have learned, particularly in Western Canada now, is that deciduous species like aspen and birch and maple can play a really important role in changing fire behavior. And so there are a lot of calls for an increased reintroduction of or stop suppression of deciduous species as a means to change fire behavior, as some of them have very high growth rates. They also have different albedo, so they change the reflectivity of the surface, and they are deciduous. So in the winter, you can see the snow, again, positive for climate balances. But the one key issue, and this is where the collaboration with governments has to come in, we need to increase the market for the deciduous tree species and the value they can generate as long-term, in long-term wood products or in other uses. And so once we can encourage their economic value and we acknowledge their fire contribution to reducing fire risks, I think we will see a lot more deciduous species back in the landscape in the future. And finally, they also have, of course, an important biodiversity role to play.
Okay, next question, Robert.
Certainly. So since more than 80% of greenhouse gas emissions come from fossil fuels Energy transition is the key to achieve greenhouse gas emission reduction. Bioenergy indeed will release CO2 into the atmosphere, but it will also displace fossil fuels. Carbon in bioproducts will stay for a long time for sure, but it will not contribute to the energy transition. To look at the large picture, should it be better to divert fossil fuels for materials production, e.g. plastics, which keep carbon from being released, while using biomass residues as renewable energy to displace fossil fuels?
So Warren, maybe you could answer that question, please.
Sure. And Tony, this is a great question. I think one way to look at it is, are we replacing like to like? So is it just going to be a bioplastic instead of a petroleum plastic? And is the use and application going to be exactly the same? Or better, is it going to be a bioplastic that has superior properties? It could be recycled. It's easier to recycle. It's easier to keep in use. We can store the carbon or sequester the carbon in those products for a longer period. I think if the answer is the latter, then it starts to look much more positive than if it's the former. You know, I actually think that a big part of the problem with our society is that the products that we use and the way that we use them just is inherently unsustainable, that we do too much throwaway, we use too much single-use material, and then we toss it. We need to find ways to increase that. And I think there are ways to do it with bioplastics. Last thing I'll say, when I say that bioplastics could be really good, I certainly don't see it displacing lumber. I could see it displacing pulp, you know, because right now we've got, let's say 40% of our biomass going into pulp, and that number is decreasing over time. This would be a nice alternative, and I bet we can make it look better than paper if we do it right.
Can I maybe just
for that, Warren. So next question, Robert.
Well, I was just going to let Diane. Diane indicated she had a supplemental.
Okay. Over to you,
Yeah.
Diane.
Yeah, so I totally agree with what Warren was saying, but I would also put it in the sense that, you know, we're not picking one product over another. It's all of those products and using the right part of the tree and the right part of the process to establish all of those products. One, to increase more opportunity to gain value from every tree cut and with the multiple products, but also to start building the circular economy that Warren is referring to. You know, so it's not, you know, when I look at the opportunities in British Columbia, one of producing lignin, well, it's a great spinoff from a pulping process that we have in British Columbia to produce lignin. So it's just another step. You know, if we have pellet production that's going overseas to replace, or maybe Alberta to replace coal energy generation, well, maybe we can get to the point where those pellets are also used for additive biomaterial products as well. So they become feedstock as well as an end product. So it's, you have to look at the whole system of products and the availability. And I think that's where we gain inroads.
Thank you for that, Diane. Robert, I think we have time for 2 more questions.
Okay, I mean, the first one is around the circular economy, and there's a question regarding what is happening with the federal government, and understanding we don't have a federal government representative. Perhaps the question is what could or should the federal government be doing in addition to what they're doing now that would incentivize the circular economy aspect of the use of wood products?
So I think that's a question for you, Warren, since you're the big proponent here.
Well, I can start, and maybe my colleagues will want to jump in. I would remind everybody online that forests are primarily provincial responsibilities. And so the type of policy that I would hope to see at the federal level would be a policy that would create the right environment for really effective provincial policies that can push us forward. And one way to do it might be to introduce policies that recognize that carbon sequestration. You know, right now we have a price on carbon, and that's a transactional kind of a policy. It's helpful but maybe not that helpful when we think about the very long-term and high-value applications that are out there. We have a clean fuel standard, which is going to steer some energy use and is probably going to support some bioenergy development or biofuel development. But what we are missing, I think, is a strategy or a policy that could help us to grow the carbon stocks, and not just the growing stocks in the trees, but the harvested wood products and that side of things. And I think if that was designed in the right way at the federal level, the provincial bioeconomy strategies that are being developed by BC and other places could slot into it and use that kind of a scaffold to really make some impact.
So Diane, would you like to provide a supplemental comment to that?
I think it's a great question. It's a very timely question. Warren referred to the clean fuel standard, and we have seen activity by investors and production facilities looking at what it's going to take to do that. So government has a role with sending messages of what it's wanting to achieve. And that's a really good example of a message that was sent out. From those messages, creates the opportunity for investment and innovation. Without those messages and a clear path forward, then it's ad hocery, it's entrepreneurial, and there is less of a solid ground when you know that government is behind you and driving some kind of activity. So being part of a provincial government, we know that we have tools. And it's whether the government, the elected officials want to utilize those tools or not. They could be regulatory tools, they could be incentive tools, they could be taxation tools, they could be, there's a myriad of tools that government has. And I think it's just looking at where the province or the nation wants to be and being very clear on what that will look like and creating the tools to help push it forward.
So Werner, you wanted to add a comment about codes and standards?
Yeah, I mean, another example of what we just talked about is our building codes, right? So British Columbia and Gordon Campbell in 2008, helped change the building code to allow 6-story buildings, and gave special exemptions for 18-story buildings, such as the Brock's Common, building at UBC. So those are all examples where, government leadership can open up pathways to innovation. And those, I think, are what we need to look for. And those are ways in which we can, really make a change in the long term.
So Robert, I think we've run out of time. So I think we ended up actually on a very interesting question, and with really excellent responses by all 3 presenters. So at this stage, it's my duty to close out this webinar, and again to thank the 3 presenters in particular for not only excellent presentations, but also for very thoughtful responses to the queries, which by and large were also very thoughtful. So really appreciate the attention by our audience and by Diane, Werner, and Warren for having provided very thoughtful responses. So thank you all for participating in this webinar. And at this stage, I will now sign off. Bye-bye.